Okay, guys, two models for a hyperbola. Okay, so we're going to draw two coordinate planes. Oh, one's bigger than the other. Okay. First of all, hyperbolas are made up of things called asymptotes. So asymptotes. Asymptotes. Oh, there's no double S's, sorry. S. Bless you. YMP. Bless you.
Thank you.
Asymptotes. ASYMP. TOTES. Okay? Asymptote is a line, a curve, comes very close to, but never touches. Okay. Think of it as like an electric fence for a dog. Okay. If your curve comes too close to the asymptote and touches it, Mrs. Cook will zap you. Okay. So actually write on your paper, zap. Okay. So both graphs have asymptotes. The asymptotes that I'm going to ask you to find are asymptotes that go through 0, 0. If the asymptotes don't go through 0, 0, I'm not going to ask you to find them. Oh, I missed a little. Okay, I'm not going to ask you to find them.
Wait,
okay?
Is that supposed to be going through 0, 0 or no?
Yes, it's supposed to be going through 0, 0. Looks kind of gnarly right at this moment.
Ooh, I like
Okay.
the word gnarly.
The vertices. A hyperbola has vertices on both sides of the axis, whether it be the x-axis or the y-axis. The pieces or the branches that I showed you have to go through the vertices. And what they do is they come very close to the asymptotes, but they do not touch the asymptotes. Or Mrs. Cook will zap you. Come very close, but not touch. Okay? All right. Distance, guys, from center to vertex. So our center is right there. Distance from center to vertex is called A. Okay? Hyperbolas do not have co-vertices. They still have points on the other axis, but those points do not have names. Okay? The distance from the center to those points is still called B.
So those are what points?
They don't have a name, and I'll show you what they do for you in a little bit when we start doing the actual real graphs. Okay? A hyperbola also has foci. The foci are somewhere inside of these branches, so out past the vertices. So you have a focus, and you have a focus. And the distance from the center to the focus is still called C. Okay? All right. The other example would be having its branches on the y-axis. So go ahead, draw some asymptotes. They just have to go through 0, 0. This time I promise I'll go through the center. Okay. So has vertices. The branches have to go through the vertices, and that's what people mess up sometime. They don't know where the branches go. And again, you'll have the points on the x-axis. Those again are your B values. Distance from center to vertex is A. And then focus. Focus. Okay, let me give you the model for the equation of the first graph. It is x squared over a squared minus y squared over b squared equals 1.
I think that it's not like the commutative property where you can switch a squared and b squared.
You are correct. You are correct. First thing we worry about most is which one comes first, x squared or y squared. Anybody know why these two are different?
Yeah, because it's the first one is on the x-axis rather than the y.
The branches? Exactly. Okay? So whatever comes first is where the branches are. Whatever comes first is where the branches are. Now, how do you explain where the a squared and the b squared go?
Based on where the vertices are?
Kind of. Go ahead, Autumn.
A squared is always going first, B squared is always going second.
Yeah. So I'm hoping that's not going to mess you up. A squared is always first for these. Always first. How's that different from ellipses?
You switch depending on your size.
Hi. The model is c squared equals a squared plus b squared. Does it matter which comes first? No, because addition is, what's that word, guys? Commutative. Very good. Okay. All right. Let me show you guys how to graph these. So, example 1 is graph x squared over 9 minus y squared over 36. Bless you, equals 1. Okay? Okay? All right. First of all, name your A and your B. Close. A is actually 3, and B is actually 6. What axis are the branches on, gang? Okay. So this is where your branches are. Okay? First step. Make your rectangle. Make your rectangle. That's the first step. So let me show you what I mean. Go to your graph paper. Okay? And On the x-axis, because it's under x, we want to go left and right 3. On the y-axis, because it's under y, we want to go up and down 6. Now, this is why I wanted you to have a straight edge. What we're going to do is we're going to make a rectangle going through these points. And because you guys told me the branches are on the x-axis, let's label these with a V, because those are your vertices, okay? Now, so we make a rectangle. And what the rectangle does is it helps you find your asymptotes. So now, okay, so number 2, draw your asymptotes, connecting the opposite corners of your rectangle. And I always do my asymptotes in a different color. Is kind of how I attack that. The asymptotes must go through 0, 0. And the asymptotes are lines. And guys, remember, lines are not lines until they have arrows on the ends. Okay, last step. Draw branches through vertices. Draw branches through vertices. So you have to stretch it out so they come very, very close to the asymptotes. But they do not touch. Otherwise, Mrs. Cook will zap you. Kill you.
Oh, that was. That's meaning where these branches go?
Yes. Remember, the branches have to go through the vertices and come very close to the asymptotes.
Okay,
So that's how you know kind of how wide. So vertices are right 3, up 0, left 3, up 0. So these we can write as plus or minus 3, 0. The foci, we actually have to calculate out, do we not? Okay. Remember, distance from center to vertice is called A. Distance from center to this point is called B. So B is 1, 2, 3, 4, 5, 6. So now we need to use our equation and find the foci. So you ready to go? C squared equals A squared plus B squared. So C squared equals 3 squared is 9. B was 6. So 36. So C squared equals 45. Square root, square root. What do you want to break it down into? 9 and 5. So 3 root 5. Plus or minus. And remember, your foci order pairs are the same as your vertice order pairs. So if it's something 0, the foci are plus or minus 3 root 5 and 0. Okay? Last thing, intercept for this asymptote. Where is it crossing the y-axis at? 0. So it's plus 0. Slope, guys, slope is from one point to another point. It's rise over run. So always count from center to one of the corners of the line, one of the corners of the box. The rise is 1, 2, 3, 4, 5, 6. The run is 1, 2, 3.